Welcome back. In the previous step, we explored a number of commands related to images. In this step, let's explore a number of commands related to containers. Earlier, we created a container by using docker run -p 5000:5000 and the repository name followed by the tag. The interesting thing is the fact that this is actually a shortcut for a command actually called docker container run. So typically what you would be using is docker run, but the thing you need to understand is actually what you are running is a container. So we are creating a container from this specific image. So you'd see that this would actually launch up a docker container. I'll use -d to launch it up in a detached mode. So you'd get the ID of the container. One of the interesting things is you can pause and unpause a container. So you can say docker container pause and give it the unique identifier. It can be a entire ID, or I can use a part of the ID, the starting 4 digits of the ID, and pressing enter. You can see that now this container would be paused. So if I try to do docker logs -f, so I'm following the logs of this specific container 6478, you'd see that the application is started up, but when I try to access the URL, I'll not get a response back because this is in a pause state. How can I unpause it? I'll do a Control C, and now I would say docker container unpause 6478, and you'd see now that you would get a response back. So pause just stops the container in that specific state. We already explored the stop command, docker container stop. It would stop a running container. You can also inspect a container. So I can say docker container inspect. This is very similar to the command that we ran on the image. So I'll say 6478 again. When you do a docker container inspect, you can see tons of details about that specific container, the image it is created from, a lot of metadata about the container itself, when it was created, what is the current status. You can see what's the platform, the details about the image, the port bindings, the volumes, a lot of stuff you'd be able to see in here. Whenever you are expecting something to happen with a container and it's not happening, probably this is the place you can look at. This would give you tons of data which you can look at and see what's going wrong. The other interesting command related to the containers is docker container prune. Before that, let's do a docker container ls-a. You can see that we have one image in a running status up 3 minutes, and most of the other images are in a exited status. And let's do a docker container prune. This would remove all the stopped containers. So yes, I would want to remove all the stopped containers. And let's now do a docker container ls-a. You can see that except for the running container, all the other containers are removed. So if you want to clear out all the containers which ran, docker container prune. Earlier, we looked at the stop command. What does the stop command do? We saw that the stop command gracefully shuts down the container. What do I mean by a graceful shutdown? Let's see that in action. If I do a docker container ls right now, you'd see that I have one container running. I want to tail the logs for it, so I'll say docker container logs -f to tail the logs. So I would want to keep following the logs which are coming out of it, and I'm entering the first 3 digits of the ID from here. So let's press it. So now we are able to tail the logs. I'll open up a new terminal. So I'm opening up a new terminal, and what I would do is docker container ls, and I'll send docker container stop 1b1. Let's see what would happen over here. You can see that at the end, after the starting of the application, there is something called shutting down executor service. So it's shutting down the executor service, it's closing the entity manager factory, and then it's dropping the table sequences, and it's shutting down the connection pool. So you can see that after I called stop on the container was given some time to finish its processes to shut down gracefully. So things like closing out the connection pool, things like shutting down the executor service, the container was given time to do all that stuff. In technical terms, when I do a container stop, the signal which is sent to the container is something called sig term. It means take about 10 seconds and make sure that you gracefully complete your execution. What I'll do is I'll do a clear and I'll start up another instance. Again, I'm using a detached mode. So I'm starting another instance of that container again. Let's go back. And now over here, I would say Docker container kill. The ID would be a little different, right? What's the ID? 9B8. Before I kill, I would actually want to check the status. So I'll say Docker logs -f 9B8. So we are following the logs. The application has started up. Let's kill it right now. Let's see what happened. The container was stopped as it is. It was not really given time to do anything. It stopped dead. In technical terms, what happens is in here, a signal called sig kill is sent out to the container and it immediately stops. The command which you should use most of the times, actually 99.99% of the times, is Docker container stop. You'd want to give your container time to shut down gracefully. Now, before we get to the next command, let's actually run Docker container prune. Before Docker container prune, make sure that you don't have any containers running. So I've stopped all the running containers and I'm doing a Docker container prune to remove all the stopped containers. I'll do yes. So we have no containers running right now. So if I do a Docker container ls-a, there are no containers down here at all. Now, what we want to do is we would want to start up our earlier application. We want to do a Docker run -p 5000 in a detached mode. Right now, we would want to add a restart policy of always. So what we are doing is we are adding --restart is equal to always. This is called a restart policy. Two of the most popular values for a restart policy are always and no. The default is no. What we are specifying right now is always. If you specify always and start this up, so I'm specifying always and starting this up, I'll do a Docker container stop 501. What I'll do over here is I'll restart the Docker desktop. Before doing a restart, let's actually list the containers which are present in here. So ls-a, you can see that this has exited out. But we have created this actually with a restart of always. So what would always do? What always does is when you restart your Docker desktop, I'm doing a restart of my Docker desktop, you would be given a warning. That's okay. Let's go ahead and restart. You can monitor the status in here. It's being stopped right now. It's now saying it's starting up. Wait until the status shows started. Okay, cool. Now it says Docker desktop is running. That's cool. And now I'm doing a Docker container ls. What's happening? You can see that the status of this container is now in running. What happened? This container is automatically started. Because we specified a --restart is equal to always, whenever you restart your Docker and the Docker daemon restarts, it sees if there are any container with the restart policy of always. If there are any, it would launch them up. The only way you can actually prevent the restart from happening is to first stop this up. So Docker container stop 501. Give it some time to gracefully shut down and do a Docker container prune. This would remove all the stopped containers. So if you do a Docker container ls right now, nothing is present. So now we have deleted that container completely. So there is nothing present right now with a restart of always. So the restart policy also is very, very useful, especially if you have things like databases which you would want to keep them always running. You can set a restart policy of always, and even if the Docker daemon restarts by accident, at the startup of the Docker daemon, that specific container would be always launched up. In this step, we looked at a number of commands related to containers. We looked at pause, unpause, inspect. We looked at prune. We looked at the difference between stop versus kill, and we looked at what is a restart policy. I hope you are having a wonderful time. There are just a few more things you would need to know before we would start actually exploring the world of creating Docker images. We would want to actually create Docker images for our REST API, for our web applications, for full stack applications and microservices. We will get there in a couple of steps. I'll see you in the next step. Until then, bye bye.